Hi. In the previous part, I explained already the level of abstraction means the common module syntax. Of the Verilog. Okay. So how to write the Verilog code of any blog and what should be the common procedure means what are the general the Verilog syntax format. So in the previous part, I explained this thing, and I already wrote the Verilog code of the half header. Okay, half header. So using the data flow modeling. Okay. So I hope you have already idea of the functionality and the behavior of the half header. So this is the two input A and B, and this is the two output sum and carry. S for sum and C for carry. Okay, so in the previous part, I explained how to write the Verilog code of half header using the data flow modeling. So in this video, I will explain how to write the Verilog code of half header using the get level modeling and behavior level modeling. Okay, so in the first part, I explained already what are the meaning of the level of abstraction. So the Verilog provide the different level of abstraction to model the any the digital block. Okay, but the functionality and behavior will not change, that is same, but there is just some syntax differences there. Okay, so in this video I will discuss get level modeling and behavior level modeling, and fourth is the switch level modeling. So this is not too much useful, actually this is useful for the analog circuit, but I already told for the if you want to design the any analog block, we have a already Verilog A. Okay, so see, so right now I'm giving idea how to write the Verilog code of half header using the gate level modeling. Okay, I hope you understand. So what I'm trying to say here. Okay, so we have a second model is the gate gate level modeling. Okay, so this is the very simple so model. When I go and in the upcoming video, so when we will start the gate level modeling discussion in the very so in the very details, then I will explain how much what are the number of the gate is there. Means the predefined gate. Which one is the predefined gate is there? All the predefined gate is there like AND gate, OR gate, NOT gate, buffer gate like that. But right now we have so we have to use only AND gate and XOR gate because of this is the I mean what are the gate level structure of the half header. So this is the very simple, just you can write like that. In the previous part also I explained. So this is the XOR gate and this is the AND gate. So in the gate level modeling, so this is the A and B is the input. So this is the XOR gate, A XOR B, and this is the A and B. Okay, I hope you know this thing already. This is the basic thing of the digital electronics. Okay, so this is the AND gate and XOR gate. So how to write the general syntax? So first of all, you should write the keyword of the gate name. So here I will use the AND gate and XOR gate because this is the XOR gate and this is the AND gate. Okay. So in the very log we have a predefined gate, AND gate and XOR gate. If you want to write the name of this gate, then you can keep here the A0, A0 for XOR gate and A1 for AND gate. You can write like that. So for AND gate, so what are the general syntax? I will discuss in very details when we will start the get level modeling. Right now I'm using this thing. And get A1, then the first thing you should write here the output. What are the output is there? Then we need to write here the input. Okay. So first thing the first thing will be output and the remaining thing is input. The same behavior of XOR gate is also means the syntax is same for XOR gate is also. Right now I named here A0, so this is the optional. If you want to write A0 A1 for this gate, it is okay. Otherwise, you can leave also. Actually, why I am writing here? Actually, we have a large number of circuit, and in that the four XOR gate and the three and gate already used. Then how can you identify which one is the AND gate and which one is the XOR gate? I mean, for simplicity, actually, I give the name of each block, like n gate A0, A1, A2, and for XOR gate X0, X1, X2. Okay, that's why I'm telling. So XOR gate here, I wrote the name for XOR gate A0. So A0, and first thing is the output, and the remaining thing is input. Okay, I hope you understand. So here I am writing the code. Just give me 1 minute. Sorry. Okay. Okay. So I already explain how can you write mm, the Verilog code, and what are the general syntax. Okay. So every Verilog code will start from the keyword module name. Okay. So here I am starting, and in the next part also, this thing I will implement on the EDF playground. Okay. So just here we'll write this is the module half header, and how many number of input is there? Two input. A comma B is the input, and S for sum, C for carry. And every statement will end with finish with the semicolon. What are the input? That is the port of the declaration A comma B, and output sum and carry. I hope you understand. And I already explained in the previous part. By default, these port are the wire type. So this all are the wire. This all are the wire data type. I mean, don't worry. In the upcoming video, I will start after 2 or 3 video. I will start the data type. So output essence. So by default, all the port is wire type. Okay. So just here I will write the predefined get name, and get and name what it is your so it is totally depend upon you. Any name you can give here for your simplicity. A1, and for end get output is C for a carry, input is A and B, semicolon. And for XOR gate, the predefined name is XOR A0 sum. I mean, sum is the output, and A and B is input. Okay, then end module. This is a very simple code for a half header using the gate level modeling. Okay, I hope you understand. And also, I am giving the idea of the third level of modeling. So this is the most important modeling, that is the behavior level modeling. Okay, behavior behavioral level modeling. So I mean, throughout the Verilog code, most of time you will use this modeling. This is the most important and highest level of abstraction also. Highest level abstraction means this is the fastest compared to the other, that like that the gate level modeling, data flow modeling. Okay, so this is the highest level of abstraction, behavior level modeling. Okay, so before the discussing of the behavior level modeling, actually I want to say something here. Actually, we have a procedural block is there. Two procedural. I will explain in very details in upcoming video. That is the initial. Okay, just give me 1 minute. Okay, so we have a two procedural block is there. One is the initial block, and one is the always block. So these two block are the initial block. If you write anything in this block, any variable, yeah, any data type, the left hand side variable must be a range type. Okay, what I told? Okay, give me 1 minute. So this is the initial and always. So these are two are the procedural block is there. Okay, I mean procedural block, and mostly initial block will use to write the test bench mostly, and always block will use to write the design. If you are designing any the digital circuit, that moment of time mostly we use the always block. Okay, so I am giving just I am writing the Verilog code here. So module half header, half header, A comma B, S for sum, C for carry. Okay, and this two is the input A comma B, and output is sum and carry. This is the output. Okay, OU to PUT. Okay, output. Now, so what I told actually, okay, I'm giving always. So the identification of the behavioral modeling is always block. Okay, when we use the always block, then definitely you are writing the Verilog code in term of the behavioral modeling. Okay, after that, here I am giving the event control. This is the event control. Okay, after that, here I can write the sensitivity list. The sensitivity list, actually right now I'm giving area. I will explain in the very details. Sensitivity list. Okay, so I mean while designing the combinational circuit, sensitivity list means if anything will be changed, this block will be executed. And one thing I am telling, if more than one statement will write inside the always block, then we need to write the begin end block. So here I need to implement sum and carry. So I mean what are the functionalities there for sum? A XOR B and carry and percentage B. Okay. So inside the always block, I wrote the two statements sum and carry. So we need to make the begin end block, just like a C language. In the C language, if we have a more than one statement, then we make the curly bracket. But in the Verilog, if we have a more than one statement, then we need to make the begin end block. Okay, begin end. This is the beginning, and after that you need to write the end module. End module. Okay, but this code is right now not okay. Okay, so this is not correct. Actually, in the some I did some mistake. Okay, what mistake? Always at gate block. So while designing the combinational circuit, half header is the combinational circuit. So half header is the combinational circuit, means this is the A and B are the two input, and the sum and carry are the two output. This is the half header. Okay, so the block, so I mean the meaning of the sensitivity list is if input A and B is changing, anything if either A या B will be changed, या both of them change, then this always block will be executed. So there are the three format is there inside this parenthesis. Here you can write the input port A comma B. You can write A comma B. Yeah, also you can write A या B. Yeah, simply you can write the star. This is the three thing is there. I mean three thing is there. This way you can write. Okay, no issue. A या B. So right now I'm giving it here, just I'm writing A comma B. I mean what are the number of input is the while designing the combinational circuit only. If we design the sequential, then we will discuss later. Okay. So I mean the meaning of the sensitivity list. If anything will be changed, then this block will be executed, and sum and carry also will the change. If A and B will change, sum and carry will be changed. So inside this block, you need to write A comma B, means how many number of input port is there. Input port A comma B. Yeah, here you can also write in the another way A या B. A या B. This way you can also write. Yeah, if you don't want to write anything, any input, just put a star, I mean asterisk symbol in this parenthesis. Okay, I hope you understand. Okay, but right now this code is also not correct. Why? Okay, give me 1 minute. So I mean if you write so actually in the previous part I already explained the about the assign keyword. So assign keyword, if you anything write a double s I G N assign keyword. So if you write the any variable with the left hand side, that must be a while. I explained now in the last part. Left hand side variable must be while. But in case of the behavioral modeling, and what the I mean how many number of the variable you are using left hand side, that must be a range tag. That must be a range tag. So if you are using the any variable inside the procedural block, like initial block and always block, there are the two procedural block is there, one initial and one always. So left hand side variable must be a range type. So there is the syntax, like if you want to write, actually I am going in the next slide. Okay, then I will write. So about the always block, just I am writing the piece of code. This is the always. Okay, and this is the begin end. Okay, so so I mean that there are some statement is there, like same way in the initial and begin end. Just I am writing here the piece of code for understanding. Okay, so if you write anything, any variable, the left hand side, suppose I am writing the any like here I am using s and c. So if you write the s comma anything a, yeah, yeah, I mean any behavior, so s any behavior, yeah, any functionality you are using, any functionality. So right now we have a for sum, that is the XOR symbol. Okay, a and b. So this variable, the left hand side variable must be a range type. This is the condition. Left, sorry, a t, this is the t. Left hand side variable, left hand side must be range type. Okay, and here is also, suppose you wrote here if you write any variable like y, and something is there like a and b, yeah, anything. So this variable should be uh, I mean the range type, must be a range type. Left hand side variable, if you are using any variable in the procedure block, left hand side variable must be a the range type. Okay, and these two variable may be range, may be while. Okay, may be range, yeah, while. So this is for also, may be range, may be while. Okay, this is also, so these two variable may be range, may be right, may be while, but s and y, left hand side variable must be a range type. So this is the very common thing, and in the most of interview, so in the most of interview we are giving, then interviewer these questions will be asked like that, why you need to define the sum and carry the range type. So this is the syntax, and this is the console. I did one mistake in code, so because of that you can understand why I am defining the range as comma c. Okay, so right now sum and carry is the range data type. So s and c is the left hand side variable. So this is the sum and so this is the range type data type. If you don't define here, then it will give the error. If you do more practice, actually I explained how to use the free Verilog compiler on the EDA playground. Just go on, watch the first video, you will get the idea. Okay, so in the next part I will demonstrate the half header on the EDA playground. I will write the code in the behavioral modeling, I already explained, and I will write the test bench also. I will give the some basic idea about that. Okay, so thank you. In the next part, I will meet. Okay, thank you.